Okay, welcome to this lecture. This lecture will be the first lecture for chapter 4, where we are going to look at linear programming, we are leaving behind the financial mathematics and we are now going to look at linear programming. Now, before we get into the details of linear programming, we will revise a little bit on linear functions and how to draw a linear function. A linear function is by definition an equation where each term is a constant or a function of a constant multiplied by an unknown variable of order 1. So from school, you know the following forms for a linear equation: y equal to a plus bx, or y equal to mx plus c, something like this. So here you can see that this is a linear function because both y and x are of order 1. So in this module we are also going to look at linear equations. If you have something like this, this is of course a quadratic equation because here my x, the last term, has an x to the power 2. So for the rest of this chapter, we are only going to look at linear equations, although we can increase the dimension of the equation by including n variables. So we can have, for example, something like this: y equal to a plus b x1 plus c x2 plus d x3, and so forth. So by adding more x variables, I'm increasing the dimension, but all of them are of order 1, so they are all linear functions. So in this module, we are going to look at linear functions in the following form: a x1 plus b x2 equal to c. So we can rewrite this in the same form like you've done at school. Here my x2 plays the same role as my y, so that will represent my vertical axis, and my x1 will represent my horizontal axis. So I can write this in the same form that you are used to. I can say that bx2 is equal to c minus ax1. So x2 is equal to, now I divide with b throughout, c over b minus a over b x1. And now we have it again in the same form as what you are used to from school. Now let's look at this example. If we want to plot the equation 2x1 plus 3x2 equal to 6, one of the easiest ways to plot this graph would be to find 2 points and then draw a line through those 2 points that will represent your graph. So an easy way would be to first of all set your x1 equal to 0. So I'm going to start by, let me just do it on another page. So 2x1 plus 3x2 is equal to 6. So I will first start by setting x1 equal to 0. So I now have a point where my x1, my horizontal value on the horizontal axis, is equal to 0, and I would like to find the value of x2. So when I substitute x1 in this equation with a 0, plus 3x2 equal to 6. So this part is just 0, and so I have 3x2 equal to 6, or else x2 equal to 6 divided by 3, which is 2. So that would be the point 0, 2. And then to find the second point, I can set my x2 equal to 0. So now I have, let me just take that out, otherwise it looks like a negative. So now I have 2x1 plus 3 times 0 is equal to 6. This part will fall away, and I have 2x1 equal to 6. So I divide with a 2 throughout, and I have x1 equal to 3. So now I have that my x1 is 3 and my x2 is 0. And I have 2 points on my graph, and I can draw a line through these 2 points, and that will give you your equation, or rather that will give you your graph. So we have the point x1 equal to 0, x2 equal to 2, so that will be that point over there, and then we have the point 3, 0, which is that point over there, and we can connect those two, and that is the graph of my equation. Now, if we look at the second one here, 2x1 minus 3x2 is equal to 4. If we want to draw it on the same graph, here you will see that the coefficient for x2 is negative. So let's do it on another page again. So we have 2x1 minus 3x2 is equal to 4. So we start by setting my x1 equal to 0. So I have 2 times 0 minus 3 times x2 equal to 4. So my x2 must be equal to negative 4 over 3. So my first point on my graph will be the point 0 minus 4 over 3. And then I set my x2 equal to 0. So I will have 2x1 minus 3 times 0 equal to 4. This part will be 0. So 2x1 equal to 4 or x1 equal to 2. So my second point on my graph will be the point 2, 0. Now for the linear programming, we always have that x1 and x2 are positive. So we will work only with the first quadrant on our graph, and therefore we won't be able to plot this point because here we have x2 negative. So in a case like this, we choose any other value for x1 that will give us a point in the first quadrant. So I'm going to choose that my x1 is equal to 4. So if I choose this x1 equal to 4, then I have 2 times 4 minus 3 times x2 is equal to 4. So I have minus 3x2 is equal to 4 minus 8, or just minus 4. So that means that my x2 must be equal to minus 4 divided by minus 3, which will give me a positive 4 over 3. So my x1 is a 4, and my x2 is positive 4 over 3. Okay, so now we can go back to our graph and draw these 2 points on the graph. My first point is where x1 is 4 and x2 is 4 over 3, or 1 1/3. So that is round about there. And my second point is the point 2, 0. So my x1 is a 2, my x2 is a 0, and that would be that point over there. And if we connect them, we get the graph for my second equation. So you can see we are working in the first quadrant where x1 is positive and x2 is positive as well. Okay, so you can use this lecture just as a revision for how to plot a linear equation.